We're going to continue to look at combination formula. So in the previous video, we were able to generate this formula, and it comes from the permutation. So when we do combination first, we assume we're doing permutation. So we got P and R. In this particular example, we got P53. So we have 5 elements that we choose 3 of them and to find out how many combination permutations we have on the top, and then for the every three of them, there are 3 letters we choose. There will be a total of 6 different permutations, which is P33. So that's how we generate this formula. To combination of n choose r is equal to permutation, r permutation of n elements divided by r permutation. And then we plugged in the formula for the permutation on the top, because the permutation formula is n factorial divided by n minus 1 factorial. So we used a little bit of algebra. We finally got this formula for combination. But if you remember that permutation has a different formula. The second formula for this is formula 1. Formula 2. We also have P of n to nr, r permutation of n elements, can be equal to n times n minus 1 times dot 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 all the way down to n minus r plus 1. So if I plug this one into the formula, into the top, and I'm going to get a slightly different formula, which is not really written in this form. So we can't in the first formula we have all factorials. It's easier to memorize in this formula. So we're going to get this permutation on the top. On the bottom is r factorial. The bottom can be written as r factorial, or to be consistent, because our top is not a factorial, I can expand the bottom to r times I minus 1, and then dot 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 dot, and then r factorial, it means we go all the way down to 1. And notice the top and the bottom, you should have the same number of numbers. And so this is a different way to do calculation. There are two formulas, either this formula or this formula. Again, this formula is easier to memorize, but to do the calculation when you have specific numbers, the second formula is easier to do. So let's look at an example. If I want to do C 10 choose 4. Now let's first use this formula to do the factorial formula. So the top will be 10 factorial divided by 4 factorial and 10 minus 4, 6 factorial. And then we are going to write down 10 factorial. That would be 10 times 9 times 8, 7, 6, 5, 4, 3, 2 times 1. And the bottom, we have 4 factorial. That's 4, 3, 2, 1, and 6 factorial, it's 6, 5, 4, 3, 2, 1. As soon as I write down this, we notice that all of these are the same as that. So if you cross them out, you're going to get just this part, right, to simplify. And to work that out, we have, say, 2 times 4 is 8. That can cancel the top 8. 3 cancels that 9 to give us a 3. 3 times 7 is 21 times 10, it's 210. Okay, so that's using that formula. As you can see, you're using this formula. It's easier to write down and remember, but this part is a little tedious. Suppose we use the second formula to do it. When we use the second formula, the top is 4 permutation of 10 elements. So we're going to start with 10, and we go down 10, 9, 8, and where do we stop? We stop at 10 minus 4 plus 1. So this is n, this is r. So 10 minus 4 is 6, 6 plus 1 is 7, so we should stop at 7. On the bottom, it's 4 factorial, so start from 4, 3, 2, 1. And as you can see, this is exactly the same as after we cancel the other 6 factorial, because 10 factorial really contains 6 factorial. That's why you can cancel all of that. So if you use this formula, you don't have to write down all of these and then cancel them out, and you will get 210. So that's why I say it's easier when you actually do the calculation of specific numbers. Easy way to memorize when to stop instead of plugging n minus r plus 1 every single time, because the top and the bottom, they should always have the same number of numbers. So you can start from the bottom to write down 4 first. Go all the way down to 1, reducing it by 1 each time. And then you start with the top number 10 and you reduce it until you have the same number of numbers as the bottom. So that will be a little quicker to memorize. Okay, so that's how we do combination with these 2 different formulas. So even some of them are variables, and maybe you have, let's say, Cn choose 4, and then you can still apply the same formula, either the first formula or the second. So if I use the second formula, I have the bottom, I start from the smaller number, 4, 3, 2, 1. The top, I start from n, reduce it by 1 every single time until I get, because the bottom has 4 numbers, I should also have 4 numbers. So each time reduce it by 1, n minus 1, n minus 2, n minus 3. Now I have 4 numbers on the top. That's when I stop. And we can multiply the bottom, because now we don't know what n is. We cannot really cancel anything, and so we're just going to have to keep it. 24 on the bottom, the top, you can either multiply them out or just leave it as this. A few special cases that we want to look at is, what is C, let's say C10 choose 0, which means you have 10 people, but you don't want to choose anybody. We cannot really plug into the formula, because in the formula, this r is not going to be 0. If r is equal to 0, we get 0 factorial, which is 0, and that's undefined when you have a 0 on the bottom. So if r is 0, what's the answer? Well, it's going to be equal to 1, because just from the definition of combination, how many, when we have 10 people, we want to choose 0 people. There's only one way to choose nobody, and that also considered as a way of a combination. So there's any number choose 0 will always be equal to 1, because this 0 means choosing nobody. Choosing nobody will be also considered as a possible way of a combination. And what if we do C10-1? And this is an easy case. If you do C10-1, which means you have 10 people and you want to choose 1, and that of course gives you 10 options. You can choose any of the 10 people. And this, if r is not equal to 0, we can still use the formula to do it. By the formula, the bottom has 1 factorial, the top has 1 number, so 10 divided by 1 will be 10. So the bottom, you start with the bottom number 1, and it's already 1 factorial is just 1 number, and the top you start with 10, and you cannot reduce it by any number, because the top and the bottom, they should have the same number of numbers. And so that's these special cases you can. So when you see n choose 0, the answer is always 1. If you do C10 choose 1 or Cn choose 1, the answer will always be n, because there are n different. You have n people. You want to choose 1 people. Of course, there are n different options.